Hi all, thank you for tuning in. Today we'll be completing both parts of Day 3 of Advent of Code 2021. So let's get started. Day 3, Binary Diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, which is your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption, which is bolded here, power consumption. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. Where's alpha and beta? The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Okay. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, there's a bunch of ones and zeros, which could be bits. Considering only the first bit of each number, there are 5 0 bits. The first bit should be the one from the right. Yes. What? That's not how I learned it in electrical engineering. Okay, so it's from left to right. Well, not electrical engineering, but yeah, but mathematics. Okay, so from left to right, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. Okay, so we just want to find the most common bit in each position. Nice. The most common value of the third, fourth, and fifth bits are 1, 1, and 0 respectively, and so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 10110 or 22 in decimal. Yeah, it's a bit confusing because the bits you go from left to right, but then you just convert it into a binary number. I mean, makes sense. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used, so the epsilon rate is 01001, or 9 in decibel. Multiplying the gamma rate by the epsilon rate produces the power consumption 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiplying them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not binary. I wonder why. Okay, so this is an instance where we should not consider these as integers. We should actually consider them as strings because we want to actually parse from left to right, and we want to parse each digit at one time. I believe, well, I wonder if they are just 5 bits in length. Let me just check our puzzle input. Okay, it's different than 5 bits, but they are all the same length. Correct. So here we iterate through the list, and then for each string element, we go through every single digit, every single character, and then count the number of ones and zeros. And we have to actually go through the entire thing before we make progress. So while iterating, we can't actually do anything other than just count it. Only at the end of iterating, then we can say, okay, this is the gamma rate and this is the epsilon rate. And then we multiply them together. Okay, so here's what I'm going to do. I'm going to have a dictionary. And the key to the dictionary is the position of the number. The position of the digit, sorry. So for example, this 00100, the 0 would be at position 0. The second 0 would be at position 1, 100. And I'm going to go through every single digit. And I'm going to count. The count will start at 0. And if the digit is a 0, I subtract 1 to the count. And if the digit is a 1, I add 1 to the count. That way at the end, I know which one is the most common. But wait, what if there's a tie? Does the question say anything about a tie? I don't see anything. I don't know what happens in the event of a tie. I assume that the puzzle input is written in a way that there are no ties. But anyways, after we go through everything, we have the dictionary indicating the position and the number. And if the number is positive, the digit at the bit at the position would be 1, and if the count is negative, the bit at the position would be 0, and that is for the gamma rate. Epsilon rate, we just inverse it. So you can actually just go through the string and then create a new string if 1 becomes 0, if 0 becomes 1. Or if there's any kind of built-in Python function that I don't know about that does this. Or if there's some kind of binary arithmetic method that can do this, like something like 2's complement. Or anyways, I don't know. So we'll just do it like that. Anyways, let's just get started. Alright, new file. Day 3. Bring my keyboard over. Day 3. Sample.txt. let's just copy this in. Are there going to be spaces? Nope, it's all good. And we can have a new Python file, day 3. So here, we can just copy the day 2. And make them all day 3s. Okay, we're good right now. So first off, what I said, I want to use the data structure of a dictionary, and I can call it I don't know, bit count. Position to bit count. No, what did I do? I'm not in Canadian Multilingual Standard, that's why I did weird stuff. Okay, it's a new dictionary. And what do we call these? Just number, I guess. So go through each digit. The number will be a string, so we can actually just iterate through the string for bit in number. And we actually need to get the position too, so position and enumerate. If the position does not exist, when we're writing, we would actually get an error message, so we don't want that. Just initialize it. The bit is 0. Subtract 1 from the count. Oh, what's wrong with my tabbing here? Huh, that's very odd. I could do an else statement since it's just 1 or 0, but I feel like an else if, so Now, normally I would do an else statement because you never know what your input could be and you don't want to get any errors. However, we assume that there is just going to be 1 and zeros, like we see it here, or here, and in the puzzle input as well. So we are safe. Okay, now that we've gone through everything, we get a count. I'm going to store that. Into what we call, is it gamma rate? Yep. Now here's where it gets a little bit tricky, since we have all the information we need in our dictionary. However, we need to put it in order. And right now, the entries are out of order because they are in a dictionary. So what I should do is just sort it beforehand. Maybe it was a bad idea to do it in a dictionary in hindsight, now that I've gone through the puzzle a bit. Because since we want it in order, why not just do it in a list? It makes a lot of sense. So for example, like bit count list initializes list. If it does not exist, we just append it. Append 0 to the end. I don't understand this tabbing. Alright, this is not enumerated. It's the second part that is enumerated. Because we will only go through the input list once, but the position is for each of the elements in that list that we have to go through again. So here, at the end, we can just go through the list again. For count and bit count list, count as less than 0? If a gamma rate, which is a string, a new string is created with the extra digit, which is 0. And if it is greater than 0, one. Now we get the gamma rate number. And honestly, we can just do it at the same time, since do the epsilon at the same time. Since it's just the inverse, makes it easier. At the end, we just return both gamma rate and epsilon multiplied by each other, I believe. We have to convert it into a decimal. Oh man. Is there a function in Python? Decimal? What is this? Binary? Return the binary representation of an integer. How do we return the integer representation of a binary? This is going to be tricky. What is int? That's why we have a good old Google or Bing. Convert. Let's just convert a string to binary. Python. It's got to be a method somehow. What? E's for geeks? That's not what I want. But that's just a binary representation of the character itself. I don't want that. Since I already have the string in binary, maybe I can just do this. Convert this string to binary. And then convert that to integer. I don't even need to do that. I can just since it's a computer, you can just do arithmetic when binary. But at the end, I have to convert it to an integer. Should this not work? I don't know. Anyways, so here we go through everything. The most common bit for each position will be our gamma rate, and the least common bit for each position will be our epsilon rate. I use a list to store all the counts. And then I go through all the counts and parse it, see if it's less than 0 or greater than 0, add the 0 and 1. I guess this looks like it's working fine. Maybe I can test it out. Day 3. Okay, test out the sample text. No, wait. What does I have here? Okay. We can actually just print out gamma rate and epsilon rate. 101 001 001. One zero one zero zero one zero zero one. That is correct. I just have to figure out how to convert this. Okay, how about if I do this? String object cannot be interpreted as an integer. But it's not an integer, it's binary. I guess it only converts a string to binary. I mean an integer to a binary. Ah, that's annoying. I don't care about the ASCII. Is there an easier way than just formatting it? Oh my god, can I just do that? Oh, there's a base parameter for int. Oh my god. So all I have to do is this. And then I get 198. Which is exactly what I want. Wow, that actually works. Simple as that. You know, really understanding a language helps with speed a lot. For example, if you didn't know this, then you had to check it up, or you would have to do it manually yourself. You know, going through each single digit of the string, and then adding 2 if it's a 1, depending on position. Adding values to the power of, adding 2 to the power of the position and it gets very messy. So having this built in is very, very useful. And we don't want a new Python file, we need a new text file. Call it day3.txt. And I'd already copied this, but okay, that's the puzzle input. Great. Now I comment this out and I uncomment this and I print it out. Now what happened? So this is only, I'm validating for dictionaries. Now let's turn to a list. We actually don't need this. This doesn't work. So position is 0, 1, 2, 3, 4. If the length of the list if the position is greater than the length of the list, or it's just equal to. So position is 0 and it's an empty list, then it's 0 equals to 0, then we have to append. But if it's greater, then the length would become 1 and the position 0 is not equal to 1. Then we don't append. Okay. Actually, I don't know if this is too superfluous, because we would only append on the first run through. So you see here, only the first line of this input do we actually just initialize it. And since they are all the same length, I feel like I can just initialize it at the start, do another for loop. Oh, what am I doing? Just go through the input list, go through that value, just append 0. Oh, you're good. I don't think we need this print statement anymore. Well, we get this answer, 741,950. And that's the right answer. Very good. Very, very good. On to part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Okay. Then, it's a bunch of rules. Oh, no. Keep only numbers selected by the bit criteria. What is that? For the type of rating value for which you are searching, discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process considering the next bit to the right. The bit criteria, okay, that's what it is. Depends on which the type of rating value you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position. Okay, we have that. And keep only numbers that with that bit in that position. Here we go. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find the CO2 scrubber rating, determine the least common value 0, 1 in the current bit position and keep only numbers with that bit in the position. If 0 and 1 are equally common, keep values with the 0 in the position being considered. But I thought there are no... I cut off there. I thought there will be no equally common because we already went through the sample. 4, 5, 6, 7, 8. It's 8 zeros, not equally common. 0, 0, 0, 0, 0, 0, 0. So nothing will be equally common. And I assume that's the same for the actual puzzle input. So what is actually going on? Hold on. This is just confusing English right now. Okay, maybe we just read through the example and it's easier to understand. For example, to determine the oxygen generator rating value using the same example diagnostic report from above, start with all 12 numbers and consider only the first bit of each number. Yep, there are more 1 bits than 0 bits, correct? So keep only the 7 numbers with a 1 in the first position. Yep. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit. Oh, of the remaining numbers. That's what's different. Okay. That's how there can be a tie. That makes a lot of sense now. Otherwise, I was just thinking, wait, we already did the first part and there are no ties. So how can there be ties in the second part? Anyways. So we just keep on going. I see. And then this is the oxygen generating of the entire input, huh? Yeah. So yep, you consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit, so keep only the 4 numbers with a 0 in the second position. In the third position, 3 of the 4 numbers have a 1, so keep those 3. In the fourth position, 2 of the 3 numbers have a 1, so keep those 2. In the fifth position, there are equal number of 0 and 1 bits, 1 each, so to find the oxygen generating, keep the number with 1 in that position. Is 1, 0, 1, 1, 1. As there is only one number left, stop. The oxygen generator rating is 10111 or 23 in decimal. And CO2 scrub rating would be the inverse, huh? Start again with all 12 numbers and consider only the first bit of each number. There are fewer 0 bits than 1 bits, so keep only the 5 numbers with 0 in the first position. Then consider the second bit of the 5 remaining numbers. There are fewer 1 bits than 0 bits, so keep only the 2 numbers with a 1 in the second position. In the third position, there are an equal number of 0 bits and 1 bits. So to find the CO2 scrubber rating, keep the number with a 0 in that position. So for the CO2 scrubber rating, if there's a tie, we take the less of it, which is 0. As there is only one number left, stop. The CO2 scrubber rating is 0.01010 or 10 in decimal. Finally, to find the life support rating, multiply the oxygen generator rating by the carbon dioxide scrubber rating to get 230. Use the binary numbers in your diagnostic report to calculate the oxygen generator rating and the carbon dioxide scrubber rating, then multiply them together. What is the life support rating of the submarine? Okay, at least I understand the problem now, so I can actually figure out a way to do it. This is going to be somewhat similar to part 1 as usual. So let's just copy part 1 for now. And replace this, that was yesterday's, from a copy and paste. So here, in the first part, I stored all the counts in a list. But here, we don't really need to do that because we are only counting one position at a time. So instead of that, I think we'll need just the current position. We obviously have to go through the entire input list again. But we don't need to iterate it twice. We actually just need number, the bit at the current position of the number. And we don't do this kind of count. We just have our own single count, which is 0. Great. At the end, we would have the correct count. And then we can do something similar to the gamma and epsilon rate. I don't need to go every single count. I should actually rename this. to most common bit. And least common bit. So 1 is for the CO2 scrubber rating, and 1 is for the oxygen generator rating. Okay, least common value. Or, on second thought, we don't actually need all this because we need to do it twice. 1 is for the oxygen generator rating and 1 is for the carbon dioxide rating. So let's just keep it, get rid of all this most common, least common bit. And just have oxygen generating bit. CO2 scrubber rating bit. If count is less than 0, both these will be assigned if count is less than 0, then 0 would be the most common, which would be for the oxygen generator rating. And the least common bit would be 1, which is for the CO2 scrubber rating bit. Okay. Now it's the same thing for count is greater than 0. But now we have an else, which is if count is equal. And in that case, this is where it differs. If they are equal, then oxygen gets 1. Is that correct? And the scrubber gets 0. And actually, if you know your electrical engineering, the results are the exact same, so we can actually just use an else statement here. It might be easier to read with the other way. But this is more cleaner, as I believe this is more cleaner at least, since there's no duplicated code. Now that we have the common bit, we actually don't need this. we want to filter the input list and go through it again. So we repeat this until there's a single element left. So in JavaScript, we would use something like we do filter. Yeah, we do filter function to the list, where if all for every element that has that bit in that position, for any element that doesn't, we would get rid of it and filter it out. So we can't really do that in Python, but I believe you can just use list concatenation, list comprehension. I mean, but wait, we can't do this yet. Because there will be two different lists. Ah, that's unfortunate. That's what I missed. So I wonder if I need to do two while loops. I don't want to do it. That's why I combined everything into one, where I have two separate lists. I'm guessing I have to because the lists are different and you go through each separate list. Not ideal. I wonder if there's an easier way to do this, but I guess not. Ay, 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 ay. Let's just copy the lists here. Okay, I don't need need to do a deep copy. It's just a bunch of strings. We stop until there's a single element left. Just have a bit. I don't need it here. Yep, that looks about right. Let's do another while loop. I gotta reset these numbers too. Bit equals that. Not oxygen, but we need the CO2. Honestly, there's some repetition here. Maybe. Let's do a helper function here. Get bit count. And we can get a input a bit list as a parameter. Now we're going to need the current position too. So let's just replace this with get bit. Part 2, get bit count. And do the same here. Okay, at least there's no duplication now, which I'm happy about. is this? Variable and function should be lowercase. Yeah, but it's CO2. How do you lowercase that? It's a chemical. It's a chemical molecule. Alright, so at the end we only have one value in the oxygen generating list. So here, if you just get that element, convert it into an integer. Same with CO2 scrubber rating list, convert it into an integer. I hope this works. X for X in list if that equals to bit. Count is less than 0. Greater or equal just becomes 0. Man, it should work. I just hope there isn't some weird issue. So let's just run it. Run the sample. Huh, it's gonna do an error, isn't it? 230. Well, it is 230. Somehow magically I got it to work. And we get this number 903A10. Submit it. Hey, it's correct. That's great. See? It feels pretty good once you just figure it out with your logic. And even though you haven't tried it, you know that your logic seems to be correct. And you run it. And it just magically pops out the right number. That's great. Anyways, today I just finished work and I'm just kind of tired and hungry, so I will just head off now. See you tomorrow.